Welcome to this explainer. Today, we're going to literally unlock the secrets of Java math operators. We're going to turn them into your very own everyday problem-solving toolbox. Seriously, if you've ever stared at a block of code and thought, how in the world does simple arithmetic control everything from basic game logic to massive data management? Well, you're in exactly the right place. Let's get into it. So, how do you translate everyday math into Java? It's a fundamental question, right? I mean, whether you're trying to figure out how to split a dinner bill with your friends, keeping tabs on live game scores, or even counting inventory in a massive warehouse, translating those real-world actions into Java code is actually way easier than you might think. It really just comes down to knowing exactly which tool to pull from your kit.
Here's our quick roadmap for the day. We're going to kick things off with basic math in Java, then we'll check out some slick programmer shortcuts, learn how to dodge the dreaded integer division trap, discover the absolute magic of the modulo, and finally, we'll wrap up with order and precedence.
Starting with Section 1, Basic Math in Java, the Foundational Tools.
All right, so just like you remember from grade school, Java gives us these 4 super familiar symbols to do the heavy lifting for all our basic arithmetic. We've got the plus sign for addition, the dash for subtraction, the little asterisk for multiplication, and the forward slash for division. Pretty straightforward.
And this actually translates beautifully to the real world. You might use addition for, say, tracking your daily exercise metrics and adding up your steps. You could use multiplication for managing event supplies, like if you're scaling up huge batches of food for a fundraiser. Or you might use subtraction for tracking your poster stock, cleanly deducting 1 from your total inventory every single time a poster is sold. See? These simple little symbols actually represent some seriously powerful real-world actions.
Moving right along to Section 2, Shortcuts and Compound Operators, also known as the lazy programmer's best friend.
So, standard assignment forces you to type out the variable name twice. You end up writing something repetitive like score equals score plus 5. Kind of tedious, right? But then you have a compound assignment, like score plus equals 5, and honestly, it's a total game changer. Instead of typing that variable name all over again, you just use a compound operator, like plus equals or minus equals. It beautifully compresses the math and the assignment into one single, highly efficient step.
Let's take that efficiency even further. If you only need to count up or down by exactly 1, the increment and decrement operators are the ultimate shortcut. Just 2 plus signs or 2 minus signs. But, and this is absolutely crucial, remember that placing the pluses before or after the variable actually changes when the addition happens. A post increment uses the current value, and then it adds 1. But a pre-increment, that adds 1 first and then uses the newly updated value. It's a super subtle difference, but trust me, it can completely flip the outcome of a complex loop.
Up next, Section 3, the integer division trap, or where on earth did my decimals go?
Okay, look at this number, exactly 12. Now, if you jump into Java and tell it to divide 100 by 8 using standard integers, the result you get is exactly 12. Wait, what? It's not 12.5. The decimal entirely vanishes into thin air. Why does that happen?
Well, the big takeaway here is that integer math aggressively chops off fractions entirely. Think of it like trying to split whole candies among a group of kids. You really can't easily hand out half a piece of candy, right? So you just distribute the whole ones and completely ignore whatever's left over. On the flip side, floating point types, like double or float, preserve the exact decimal value. And that is exactly what you need when you're doing things like dividing currency or calculating precise averages.
Also, you've got to be incredibly careful with integer division for one other major reason. If you accidentally divide a number by 0, Java isn't just going to spit out a 0 or politely ignore the mistake. No way. It will throw a massive fit, an undefined operation exception, specifically an arithmetic exception, and it will crash your calculation completely. Seriously, always double-check that your divisors are not 0. All right, Section 4, Magic of the Modulo. Cycling through tasks. Let's talk about the modulo. It's represented by the percent sign. But listen closely here. In Java, that percent sign doesn't mean percentages at all. Forget percentages. It's actually an operator that performs a division and then returns only the leftover remainder. That's it, just the remainder. So why is that useful? Well, imagine you have a constantly increasing counter, but you only have 3 repeating tasks. Like, say, a health protocol cycle where index 0 is wash hands, index 1 is wear face mask, and index 2 is maintain a 2-meter distance. You obviously can't just use a raw counter that shoots all the way up to 100, But if you use modulo 3 on that exact same counter, your answers are going to perfectly and safely cycle through 0, 1, and 2 over and over and over again.
To give you a super concrete example, if your total cycle count is exactly divisible by 3, well, the remainder is exactly 0. So that modulo 0 result essentially tells your program, hey, it's time to start the loop over and trigger the very first task, which is washing your hands. It is just a remarkably elegant way to wrap values around.
Finally, Section 5, Order and Precedence, Tracing the Math Quiz.
So, when you're throwing all these operators together, Java follows a very strict operator precedence table. Step 1 is always parentheses. They absolutely get top priority. Step 2 handles your multiplication, division, and that handy little modulo. And then finally, Step 3 comes in to tackle any addition and subtraction. Oh, and if multiple operators are sitting on the exact same level, Java just calculates them straight from left to right.
So if you're trying to trace a really complex math quiz problem, you can actually use parentheses as sort of a VIP pass. Wrapping a piece of the equation, like 5 plus 200, in parentheses forces that addition to jump the line and happen before any of the division or multiplication steps. Understanding this precedence is quite literally the key to writing accurate, bug-free equations.
Wow, okay. You now have the exact tools to add, compound, divide, completely bypass that tricky integer trap, and beautifully cycle your data using the modulo operator. So the question is, with your Java Math Toolbox now fully equipped, how are you going to apply these basic operators to build your very first program? I'm going to leave that exciting challenge up to you. Thanks so much for joining me on this explainer, and hey, happy coding!